And next, we want to know what is the kinetic energy of a ball if it has a mass of 2.3 kilograms and a speed of 12 meters per second. So it's going to be similar steps as our previous problem, where step 1 is to establish our variables. So looking at the question, we have a mass and we have a speed. So let's write these out. Mass is equal to, V is equal to. So mass is 2.3 kilograms. And V is equal to 12 meters per second. Then our unknown, what is the kinetic energy? Well, kinetic energy is our unknown. So we've got our variables established. The next step is going to be to choose which equation we're going to use. So given that we have these three variables here, the equation that we're going to use is the kinetic energy is equal to 1/2 mv squared. So now with step 3, we're going to use this equation and we're just going to plug in our variables. So step 3 is to plug in variables. Alright, so let's do that. I'm going to rewrite the equation. EK is equal to 1/2 mv squared. Now let's start plugging in these variables. So remember, EK is our unknown. Is equal to 1/2 mass, 2.3 kilograms. And then the velocity is 12 meters per second. So this one, we don't need to rearrange the equation. We already have the unknown isolated, so that makes it easier for us. So all we have to do is multiply out these numbers. I'm going to first start by multiplying these two together. And that'll give us 1.15 kilograms. It's multiplied by, and I'm actually going to also do this operation here with the 12 squared. That'll be 144 meters squared per second squared. And that is equal to E kinetic. Here, I want to write this as at least relatively neat so it's legible. And now we just have to multiply. We just have to multiply these two terms together, and that'll give us an answer of 165.6 kilogram meters squared per second squared. And you can see this is the units for joules, kilogram meter squared per second squared. And of course, it makes sense because we're looking for energy, and joules is a unit of energy. So when I'm writing out this final answer, EK is equal to, I want to keep just two significant digits because that's what we're given in the problem. And I'm going to bring this decimal back 2 spots. So it's going to be 1 point, and I'm going to round the 6 to a 7 because the following decimal is a 5. So it's going to be 1.7 times 10 to the, and remember 1, 2, so it's 10 to the 2. And the units now is joules. Remember, this units here is joules. And that is the final answer.